Thanks so much. Yeah, as mentioned, this is my first SciPy. I'm really excited to be here and talk with you guys about this tool called PYNT. I realized that the title was pretty vague, so just to give you a little bit more of a descriptive title, if I had a do-over, I'd probably call this PYNT Software Engineering with Jupyter Notebooks, and we'll get into what that means soon. But first, I am Edward Banner, that's my name, and currently I'm a data platform software engineer at Stitch Fix in San Francisco. If you know about Stitch Fix or are interested in employment opportunities, then come and chat with me. I'd love to talk with you. And so this talk is going to consist of three major parts. I'm going to give some motivation and overview of this tool called PYNT, why it exists. I'm going to spend the bulk of the time going through a feature tour of PYNT, what you can do with it, and then I'll conclude with some observations that I've seen so far as a user of PYNT and sort of what I think is interesting there. So what is PYNT? So I'll just say what it is. It's short for these two words, Python interactive. It's an interactive programming tool, and in one statement, it'll get any code that is not currently into a Jupyter Notebook into a Jupyter Notebook. So how many people here have used Jupyter Notebooks? Or okay, cool. So I don't have to introduce that, but you might ask yourself why. Why would you want to do this? Get code outside of a Jupyter Notebook into a Jupyter Notebook? Well, first of all, I really love Jupyter Notebooks. I love programming in them. I love the interactivity and just the quick feedback cycle that you get. You can evaluate snippets of code and you can iterate really fast. The second reason is to decrease network FOMO, fear of missing out. So here's where the sustainability part of this talk comes in. So I have written many an application in Jupyter Notebook that quickly devolves into kind of a mess. So I'll do a lot of copy and pasting in a Jupyter Notebook. They get fairly long. And I sort of put off good software engineering practices, like taking my code and putting them into a function, and then maybe saving that out to a .py file and importing that function and just calling it in the Jupyter Notebook. And the reason that I put that off is because once you've made that leap to take your code and put it into a function, you lose the ability in the future to, if you want to modify that function, to evaluate little bits of it in a Jupyter Notebook. That code is kind of locked away in the body of that function, and you've sort of gone to the point with no return there. So I wanted to create a tool that would not penalize you for doing that. You can take your code, you can do good software engineering practices, you can take your code, put it into a function, save it into a file, and easily get it back into a Jupyter Notebook so you can extend it, play around with it, understand the parts. And the more immediate reason why I built this tool was because I was already using Jupyter Notebooks to develop code in a sort of hacky way. And here's kind of what that looks like. So this was my workflow pre-PYNT. This is just a text editor on the left-hand side and a Jupyter Notebook on the right-hand side. So we have some code here, which is called image size, and it computes the size of an image at this URL. So it'll download the image and then do a conversion and then take the size. If we wanted to extend this code just a little bit by additionally resizing the image, well, we could kind of reason about the code and realize it's only a one-line change. We could just resize the image right there. This would just be coding like normal. But here's an alternative way to do it, which I do a lot. The first thing I'll do is I'll take the code in the body of this function, I'll copy and paste it into a Jupyter Notebook. I'll then identify the three main parts of this code. I can see that we're making an HTTP request, we are downloading the image, we're doing a conversion, and then we're getting the size. I'll then add the imports, so we're getting closer to actually being able to run this in the notebook. Because this code is in a function, and this function takes an argument, we need to grab an image URL from somewhere. So now we're at the point where we can actually run this code and get a better idea about what kind of intermediate data is computed in the body of this function. Once we've done that, we can now have an environment where we can write some code to resize the image, write that code, evaluate that code, see the change, and then once we're happy with it, we can take that code, we can merge some cells, we can copy and paste that back into the original code, and we're more confident that we've done the right thing because we've already seen the result, and It's also just a little bit more fun too. Than it's kind of like shooting in the dark. Like if you just make a change to the code. So what did we just do? This consists of a few steps. We selected a region of code. We pasted it into the Jupyter Notebook. We did some splitting of cells. And then we played around for a while and then pasted the code back into the Jupyter Notebook. So the only thing that PYNT does, maybe I'm not giving it enough credit, but it's a tool to automatically do those first 3 steps. It allows you to identify a region of code, paste it into a notebook, and do some cell splitting. So let's get into PYNT and see and see kind of what it looks like. So the first thing that I just have to get out of the way is PYNT is a plugin, not that you can use with a regular Jupyter Notebook, but it uses this thing called the Emacs IPython Notebook. And so what is that? Well, so the first thing involved with this is Emacs. Emacs is a text editor. It's very customizable, extendable, and it's been around for decades. Many a professional software engineer write production code every single day with this. And the Emacs IPython Notebook is just a plugin in Emacs, which basically gives you a Jupyter Notebook in your text editor. Yeah. So for the purpose of this talk, the Emacs IPython Notebook is equivalent to the good old-fashioned Jupyter Notebook that we all know and love and that we're familiar with. But PYNT works in the Emacs IPython Notebook. Okay, so let's go through a feature tour of PYNT and what you can do with it. So the first thing that PYNT kind of does for you is some Jupyter Notebook management. So we've got this code which is the example that we saw before, which downloads an image, does a conversion, and then grabs the size. The first thing that we can see with PYNT here is that we can hit a keystroke and it'll automatically create a Jupyter Notebook in the same directory as where this script lives. So that's kind of cool. Just with a keystroke, you get a Jupyter Notebook for free that you can then play around with. Okay, so let's talk about code dumping in PYNT here. So now that we've got a Jupyter Notebook, we can hit another keystroke to that in one shot, takes all the code, dumps it into the Jupyter Notebook, and splits up all these cells so that when you run all the cells, you can get a view of what we had before of the intermediate data that's computed in this script. So we can scroll around and we can actually see the data in addition to the code and see what this code is doing. So PYNT is code region aware. What that means is that, okay, so we have our code here, and since we're good software engineers, we see that maybe we'll want to compute the size of various images. So let's take that code and wrap it in a function called image size. Now, with a keystroke, since our cursor is at the top here, there's code outside of any function. So if we hit a keystroke, we'll create a Jupyter Notebook and dump that code in there and split up the cells. But if we cursor down to this function here, we can hit the same keystroke and dump the code in the body of this function into a Jupyter Notebook so that when we do a cell run all, we can get the intermediate data again and play around with it and maybe add some functionality or debug this function. Code notebook scrolling, this is kind of the easiest slide just to sit back and let you look at it. So in this case, there are 2 code regions in this Python script here. There's 2 functions. As we're scrolling around in the code, there are 2 different Jupyter Notebooks for each of these code regions, and the Jupyter Notebook is switching out with each of these regions, and it's scrolling automatically. Setting up state via doc test. So we took that code in that script and we just wrapped it in a function, but we cheated a little bit because this function takes a URL, but we just hard-coded a URL right here. In general, we're not going to want to do that, so let's take that away. But if we generate a Jupyter Notebook, notice that PYNT parsed out what arguments that this function takes. If we evaluate this code cell here, well, the variable URL is not defined. We don't have an image to grab, so that's a problem. Well, one way that you can get around this, just so you have a value for the arguments of this function, so that you can evaluate the code and play around with it, is to stick a doc test style code snippet in the doc string of this function here. PYNT will pick that up, dump it into the corresponding Jupyter Notebook so that when you run all the cells, that variable is set to something, so you can evaluate the rest of the code and see the intermediate data and play around with this code. You can also, if you document your functions a little bit more with more documentation, then PYNT also picks up the part of the doc string that's not a doc test code snippet. On the right there, you can see that. Okay, so here's where it gets really fun, in my opinion. This is my favorite part of PYNT. It's this slew of features called code lifting. So since we're good software engineers, we know that when we make a request to download something, stuff can go wrong. We might be given a bad URL, or maybe we don't have internet access, and this request call might fail here. So let's wrap it in a trylexcept block. So if there's an error, then we'll catch that and we'll return something sensible. Now, if we just generate a Jupyter Notebook and dump this code again, well, PYNT has this alignment between expressions in your code and code cells. So it treats this trylexcept block as a whole expression by itself, so it puts it into one code cell. If we run all the cells, well, the right thing happened, and the body of that trylexcept expression ran, but now we can't see the intermediate data that flows through this function. Now, with a keystroke, we can kind of lift or unpack or explode this trylexcept block. So we push up the code in the body of the try to the top level. So now that when we run all the cells, everything's at the top level now, and we can see the intermediate data again and extend this original code and scroll around. So this is effectively what we've done with this code lifting feature. We've just rewritten a trylexcept block and kind of flattened it out. So the Python try got replaced just with a comment try. The code in the body of the try just got pushed right below that comment, and the same thing with the exception clause. We can, there's also code lifting for conditionals. So in this case, we have augmented our image size function with a new argument called new size. And if that's passed in, then we'll resize the image. If we run all the cells, then we can see that everything ran, but this resize operation is kind of buried away in the body of this conditional. So we don't actually see that resized image, so we can't really verify that visually that the right thing happened. We can, once again, hit a keystroke and lift the code in the body of this if up to the top level. And now if we run all the code cells again, then we can see at the bottom the smaller image there with the cat, and we can visually see that, okay, we were able to resize this image and we're happy with it. Maybe we'll change that or extend it, or we're done with it. There's also lifting for loops too, so taking the code in the body of the for loop and also promoting that to the top level. I think I'm going to skip over that one because it's a more advanced example. And so there are two more features that I want to just talk a little bit about: breakpoints. So recall that in order to give this argument URL a value so we could run the code that comes after it, we included this doc test style code snippet there to set it to something. Well, in a code base of any significant size, you're probably not going to want to litter your code base with a bunch of doc tests. So let's take that out. But now if we generate the course, we dump the code in the body of the function and we run this, well, we're back to the same problem. URL does not have a value. To get around this, let's add some code which actually calls our function image size, which is the function that contains the code that we want to interact with and play around with. And so in this case, let's actually call this script. So when we call this script, that if name is main block is going to get executed, and it's going to call our function. And what's going to happen is within this PYNT tool, PYNT knows that we are currently looking at the image size function. So it inserts a breakpoint in that function. So when the script runs and this image size function gets called, it basically hits a breakpoint which spawns an IPython kernel, which you can then restart this Jupyter Notebook and attach to. And that IPython kernel will have all the local variables at the time that the breakpoint was hit when this function entered. So this value of URL that was passed into this function is there, and now we can evaluate all the code in the body of that function. And so the last feature is really related to this to the previous feature. Now, if we give this function a bad URL and it raises an uncaught exception, for example, we change down here, we change this URL to a bad URL. When we run this code, when we run this script, image size is going to get called. It's going to try and make that request. It's a bad URL, so an exception is raised, and it's uncaught. We can see that at line 9 here, that exception was hit. And then the script exits, just like you would expect. But if we insert these 2 lines here, up at the top, we register we do this register thing. The next time that we call this script, that same exception is going to be hit, but instead of that exception being raised and uncaught and the program just terminated, PYNT will actually catch that top level exception, start an IPython kernel that contains the state of your program at the time that this exception occurred. So the effect is you are able to then, once again, evaluate the body of this function, play around with this code, and inspect why the crash happened, and take some precautions to prevent that in the future. So those were the features that I wanted to get across with PYNT. Just for a summary, we went over some Jupyter Notebook management features with scrolling the notebook. We can dump code from your code file into a Jupyter Notebook and split up cells. We can do unpacking or code lifting for several kinds of expressions. We can set up the state required to play around with or evaluate any code in any code base that we want to, and yeah, that's that right there. So I just want to conclude. I'd like to conclude by just mentioning some observations that I've run into so far. So whenever you create a new tool, software engineers in general are pretty skeptical of that tool, and a first question that they'll ask you is they'll say, okay, it sounds cool, but what have you actually built with it? So my answer to that question is I build PYNT with PYNT. So I bootstrapped it as quickly as possible to get it to a point that I could use the tool to develop the tool. And I've also built a little Django web app. So this is more of just a proof of concept that using a framework which does a bunch of setup magic, that this tool can actually allow you to interact with any code in any part of a Django project. And some early lessons that I've encountered. So from a software sustainability point of view, one unfortunate thing. You don't need help to write bad code, okay. Well, PYNT makes it even easier to write really bad code. Because of those code lifting features that allow you to basically dive into any kind of like spaghetti code and unpack code and push it up to the top level, you'll stare at code like this, which has several levels of conditionals and looping, and be like, no problem. I know exactly what's going on here. So that's kind of a downside, but you'll have a lot of fun while doing it. I can guarantee you that. And so one other kind of downside is it's pretty easy to get tunnel vision with PYNT. So the reason that one compelling reason I think on paper with PYNT is that when you are developing code not in a Jupyter notebook, you can make a code change somewhere in a code base. In order to figure out if it's right, you just kind of run all the code and see the output and like kind of guess as to whether you got it right or not, or like made the change that you thought you made the correct change. And PYNT allows you to really dig in and focus on a very specific part of a code base and see the data and like play around with it and visualize it. But comes at a kind of unexpected cost, where it's kind of easy to get focused in on a little part of a code base and like do a lot of playing around, but at the expense of kind of forgetting about how your code fits into a larger system and what it's calling and what calls it. PYNT is a little bit in trouble. So I only know of two people who have concretely expressed any interest in actually using PYNT other than myself. I had one GitHub issue where someone was trying to get it running, and I helped them as best as I could. And I had a comment on one YouTube video. But basically, the barrier to entry is very, very high. You basically have to be an expert in Emacs and also Jupyter Notebooks and also Emacs IPython Notebook to be able to use this thing. So that's a big problem, and I'm not so sure if there's a good answer for that. So I'd be remiss if I didn't mention some other tools which I think have some of the same design goals as PYNT, which allows you to really see data and code side by side. I was really impressed. I didn't even know about this, but PyCharm has a great visual debugger. As you're stepping through code, it'll actually stick the data right next to code variable assignment statements to allow you to see kind of what's going on. And there's this other editor called Atom, which has a plugin called Hydrogen, which allows you to see rich visualizations in line kind of below your code. So I think that's a really cool tool, which is great. So I'm kind of asking this open question. I'm not really sure what the future of PYNT is. If it's not some project that really takes off and a lot of people start using it, maybe there are pieces or components of it that people would find interest in. So one way that you can look at PYNT is it is a code to Jupyter Notebook converter, which I think has maybe some interesting applications, and I'm sure that people could come up with interesting ways to kind of use a tool like that and might find it useful. One feature that I had to implement along the way with PYNT was to allow Jupyter Notebooks to attach to an existing IPython kernel that was started outside of a Jupyter Notebook. If that doesn't make any sense to you, don't worry about it, but on the chance that someone has ever tried to get that working and you want to know how I did it, I'd be happy to chat about that. And I know at least some other people have tried to do this and they were interested in it, so maybe trying to get that accepted into core Jupyter itself would be of interest to some people. So maybe making PYNT also a Jupyter Lab plugin. So if you've seen this presentation and you just say like, oh, I'm never going to use Emacs, like that's not for me. But if that thing was a Jupyter Lab plugin, I would totally use that. Then maybe there are some people that would have that reaction, and that'd be a way to go. Maybe just kind of dropping PYNT and focusing my efforts at least on a tool like Hydrogen or PyCharm, which has similar features, which has more people actually using them, would be a way to go. And also kind of narrowing in on the niche for PYNT. My original goal was to make it so software engineers that knew nothing about Jupyter Notebooks would find a useful tool in them to be able to aid their development of software. So I kind of had in mind this target, like experts, software engineer, and like design PYNT with him or her in mind. But some of the features of PYNT, really, it's about taking some code that's in a code base somewhere and digging into it and interacting with it and exploring it and kind of understanding and getting a sense for it. So maybe a better niche for PYNT is people who are newer to software engineering, and maybe that's where Jupyter Lab plugin might be more accessible and useful for them. Thanks. Take some questions.
So thanks so much for a great talk. I also really appreciated the picture of the cat as the image resizing example. Are there any questions? It's bright up here too. Questions? I'm going to bring you the microphone so that you can be heard.
Hi, so that was a great presentation, and I have a question. So the first bullet point towards the end where you said, you could just think of this as a code to Jupyter Notebooks converter. How easily do you think this could be extended to be beyond Python code? You could use it to just convert SAS to Jupyter Notebooks, jQuery, JSON, whatever it is, any language.
Yeah, so that's a really good question. So how Python dependent is the feature of taking code and converting it to a Jupyter notebook? So the answer to that question is really the biggest dependence on Python, I think, comes in when you're doing these code lifting rules. Python has this great library called AST, which is short for abstract syntax trees. It allows you to take code like this and parse it and just deal with the expressions in an abstract syntax tree and do these code lifting rewrites. I think that's where a lot of the magic with PYNT actually really is, and it's the thing that I enjoy doing it the most. So insofar as the language that you're targeting has a good library for parsing code and being able to do these syntax rewrites, that's kind of a limiting factor. The other limiting factor would be the features with breakpoints and exception handling. So both of those features rely on the IPython kernel machinery to make it so anywhere in your in the code base that you're dealing with to just drop in a statement like ipython.start kernel to start up a kernel and capture all the state of your program at any time. That is very Python specific, and I think it's really there's been a lot of work to create that functionality and make it very stable. So those are the two areas where it might be difficult to extend it to other languages. But the point is this generates Jupyter Notebooks, and Jupyter Notebooks are this language independent thing, at least as advertised. So that's kind of a point for making this tool work with other languages.
Questions?
So is the parsing to extract the code over to the notebook done using eLisp and underlying Emacs?
So the code that actually parses the Python and does the lifting as is pictured here, that's done in Python. Yeah, so it's with that Python abstract syntax tree AST module. So Emacs is calling out to Python, the parsing is happening there, and then Python will send back this parsed lifted code back to Emacs, and then the Emacs part is kind of dumb. It just dumps this code into Jupyter Notebooks, into the Jupyter Notebook. Sorry.
Hey, I'm a SpaceMax user, and I'm definitely interested by this kind of workflow, so I'm going to give it a try later on, and I know at least 2 people around me that probably are very keen on this kind of stuff as well. Oh, nice. Yeah, I'm interested somehow, because I Google this every 2 years or so, to try to find something that is a mix of having a source file and having an interactive Python console where you can play with stuff and go back to the source file and these kind of things. And you kind of hinted that maintainability is kind of tough, right? Because generally this project is for it's changed the maintainer, the guy wasn't responding, and it's quite tricky. So what's your take on this kind of stuff? How likely is it that it's going to be maintained for some time at least? Or
so your question is, do I think that Emacs IPython Notebook is going to be a well-maintained tool going forward?
PYNT.
Oh, will PYNT be well maintained so far? So it's really optimized for my use cases and the code that I'm dealing with. So I'd be willing to bet the second that you try to use it with your code, you're going to be doing something slightly different than me. So it's probably going to break for you. So as long as I'm using it, as long as I'm pretty much the only one who's using it, it's probably going to be difficult for anyone else to use it. But this is kind of a pattern with any software project. One person starts using it, and it works for them, but other people are interested enough to start banging on it, and bugs get found and bugs get fixed, and that's how it evolves. So it's going to be a question as to whether other people find it useful or not.
All right, I think that's all the time we have for questions. So let's thank Edward again, and he'll be here for any other questions.